Why measuring production indicators is essential in manufacturing. In today's competitive manufacturing environment, tracking production performance isn't just a nice to have, it's a must. Manufacturers face intense pressure to produce high quality products efficiently, economically, and with minimal waste and downtime. You've likely heard the saying, what gets measured gets managed. This rings especially true on the factory floor. If you don't measure your production processes, it's nearly impossible to identify inefficiencies or improve them. By measuring key production indicators, companies can pinpoint exactly where time and resources are being lost, enabling continuous improvement that boosts efficiency, quality, and profitability. In short, measuring production is essential for uncovering hidden problems and staying competitive. One of the most important metrics for manufacturing performance is overall equipment effectiveness, or OEE. OEE provides a single powerful gauge of how close your operations are to perfect production, making only good parts as fast as possible with no downtime. In fact, OEE is often considered the gold standard KPI for manufacturing productivity. It measures the overall effectiveness of a manufacturing process by combining three essential parameters: availability, performance, and quality. Each of these factors captures a different aspect of efficiency, and together they explain where your production time is being lost. By monitoring OEE over time, companies gain a clear, objective baseline of how their equipment is running and can track improvements or declines in productivity. Crucially, OEE doesn't just give one big number. It breaks that number down into components that point to specific problem areas. Let's break down each component and see why it matters. Availability measures uptime, the percentage of scheduled production time that the equipment is actually running. Whenever a machine is supposed to be producing but isn't, whether due to an unexpected breakdown or a planned pause, it hurts availability. Every factory machine inevitably stands idle at times due to stops. For example, unplanned breakdowns, maintenance, or changeovers between products. Availability is calculated as runtime divided by planned production time. So, any downtime, any stop time, lowers this factor. In other words, if you schedule an 8-hour shift but the line runs for only 6 hours, your availability is 6 over 8, that's 75%. Losses here typically come from equipment failures, setup adjustments, or any event that halts production for more than a few minutes. By tracking availability, managers can see how much time is lost to shutdowns and then dig into the reasons, whether it's lengthy changeovers, frequent breakdowns, or material shortages, and take action to reduce those delays. A high availability means your machines are up and running as much as possible, which is critical for meeting production targets. Even when machines are running, meaning availability is high, they might not be running at their optimal speed. This is where performance comes in. Performance measures how fast the operation is compared to its theoretical maximum speed. It's essentially the ratio of actual output to the output you should get in the time the machine was running, if it ran at 100% of its designed speed. For example, if a machine could ideally produce 100 units per hour, but due to slow cycles or minor stoppages, it averages only 80 units per hour, the performance score would be 80 over 100 or 80%. Performance losses include anything that makes the process run slower than its ideal rate. This could be slow cycle times, idling or small stops, or suboptimal feeding of materials. Common causes might be worn-out equipment, substandard materials causing jams, or operators running the line below top speed. While availability tells us how often were we running, the performance asks, when we were running, how close to top speed were we? By measuring performance, you uncover hidden capacity, the extra output you could get by eliminating inefficiencies like slowdowns and microstops. A high performance rate means the process is operating briskly without slowdowns whenever it's up. The third OEE component is quality, which focuses on output that meets quality standards. It answers the question, of all the units produced, how many were good and sellable versus defective? Even a fast and frequently running machine isn't truly effective if a chunk of what it produces ends up as scrap or requires rework. Quality is calculated as the ratio of good products to total products made. For example, if you produced 100 units but 5 were rejects, your quality score would be 95%. Losses in quality come from manufacturing parts that fail inspection or need rework, in other words, defects and rejects. Factors affecting quality include equipment calibration, raw material consistency, or process control issues that lead to defects. Monitoring the quality metric highlights issues in the process that hurt yield. For example, if quality is low, you might investigate frequent defects, operator errors, or startup scrap. A high quality percentage means very little waste, almost everything produced is usable, which directly improves the bottom line. Remember, producing 100 units when 20 are unusable is effectively like producing only 80 good units. Quality measurement ensures you account for that loss. To see why these metrics matter, let's consider a practical example. Imagine a production line rated to output 100 units per hour. In an ideal 8-hour shift, that's 480 minutes, with no stops and perfect efficiency, it could produce 8 times 100 equals 800 units, but at the end of the day, you find that only 300 good units left the line. What happened to the other 500? OEE and its components help explain this gap. Availability loss. First, suppose the line was down for a total of 2 hours due to a mechanical failure and a long changeover. That's 2 hours of lost production time. Instead of the full 8 hours, the line ran only 6 hours. That's 75% availability. 6 over 8 hours. In terms of units, those 2 hours of downtime cost 200 units of output, since at 100 per hour, 200 units were never made during the stoppages. Availability losses are often the largest chunk of lost production time, so reducing downtime directly recovers those lost units. Performance loss. Next, during the 6 hours the line was actually running, it didn't always run at the full 100 units per hour rate. Small stops and slow cycles, perhaps due to minor jams, cleaning, or just running below optimal speed, meant the line's actual throughput was lower. Let's say in those 6 hours of runtime, it could have produced 600 units, 6 hours times 100 per hour, but it only produced 350 units due to these speed losses. That's a performance of about 58.3%, 350 over 600. In other words, 250 units were lost because the line ran slower than its theoretical capacity. This performance gap could be due to many small inefficiencies, and measuring it flags that there's significant room to speed up the process. Quality loss. Finally, out of the 350 units produced, not all passed quality control. Imagine 50 units were defective, scrapped or needing rework, leaving 300 good units that were actually sellable. That's a quality rate of 85.7%, 300 over 350. Those 50 defective units represent wasted effort and materials. The line produced them, but they didn't contribute to saleable output. By tracking this, the team knows to investigate why so many defects occurred. For example, was there a particular machine causing rejects or a raw material issue? Now, if we multiply these 3 component rates together, availability, 75%, times performance, about 58.3%, times quality, 85.7%, we get an OEE around 37.5% for that shift, which matches the outcome, 300 good units out of an 800 unit capacity. Each OEE component shines a light on a different source of loss, downtime, slow throughput, and quality fallout. In our example, the availability loss, downtime, cost 25% of potential output, performance issues ate another chunk, and quality problems took away the rest, explaining why the final count was so low. This example illustrates why measuring production indicators like OEE is so critical. Without hard numbers, one might only see the end result, 300 units produced, and struggle to know why it wasn't higher. OEE breaks the problem down, showing whether the biggest losses came from downtime, speed, or quality. Armed with this data, manufacturing teams can target the right area for improvement, maybe maintenance to boost availability, process optimization to improve performance, or quality control to reduce defects. Over time, steadily improving each factor will raise the overall OEE, meaning more products out the door and less waste in the process. In summary, measuring production metrics is essential for any manufacturer aiming to improve. It provides transparency and actionable insight, from spotting hidden bottlenecks to revealing waste that erodes profitability. In a world where efficiency and quality determine competitiveness, you can only manage and improve what you measure. By tracking indicators like OEE and its components, factory managers and engineers create a culture of continuous improvement. one where data drives decisions, and each day's production can be better than the last. The result is a more efficient, competitive operation that can consistently deliver on targets and adapt to challenges, all thanks to the power of measuring what matters. Thank you for assisting, and keep tuning in to Pina Dynamics for more insights and innovation.